In this video, I'm going to describe 4 types of flow which can be encountered in fluids. 3 of these are significant in scramjets, but I'll include the other one for completeness. Firstly, when a gas is moving slowly, its molecules have time to rearrange themselves when they encounter an obstacle, or when an obstacle moves through them. This means that the density of the gas is basically constant. We call this type of flow incompressible flow. And apart from slow-moving gases, the equations developed using this assumption also apply to liquids. This type of flow is not normally encountered when we think about scramjets. In the second type of flow, the fluid starts moving more quickly, and the atoms and molecules in it can't move fast enough to get out of the way when an object is moving through them. And so the flow compresses them around it. Density is no longer a constant. This starts happening generally at around about 1/3 of the speed of sound. The squashing of the molecules and the friction between them with viscosity causes the flow to heat up, and so we must take heat into account when we're developing equations for this type of flow. This flow between about 1/3 of the speed of sound and the speed of sound is called compressible flow. Now we reach the speed of sound. The molecules now really can't get out of the way. They simply can't move fast enough when an object moves through them, and so they pile up in front of any object. And this causes a severe discontinuity in the flow, which is called a shock wave. Shock waves dominate these flows above the speed of sound, and these are generally called supersonic flows. Finally, when the flow is so energized and hot that its components start reacting with each other chemically, this is termed hypersonic flow, and is usually defined to start around Mach 5 and continues above this.